Well, welcome students to another lesson. In today's class, we will be looking at superposition. So superposition theorem, right? So basically, what you want to do for superposition theorem is that you want to first simplify the circuit, right? So let's look at a quick example. Alright, let's say, so we use superposition when we have a current source and a voltage source. So first, what you're going to do is, let's say for example you're given a circuit, right? You're going to first use the current source, and then secondly you're going to use voltage source. And when you're doing this, you should know that you should ignore the rest of the circuits. So if you're focusing on current, you should ignore the voltage, and if you're focusing on the voltage, you should ignore the current, right? And then you find what you're looking for. So the next step would be find answer, and then find answer, right? And what you want to do then is basically like Kirchhoff, you are looking for current, right? So you are looking for current in the branches, right? And then finally what you're going to do for your final step number 3, is going to add the two sources. So you're gonna add, this is gonna be a 1 and this is going to be 2. So 1 plus 2, and then that will be your final answer. Right? Is that clear enough? Okay, so apparently I got only one question, same as last week. So the question was for the problem number 2. So problem number 2 has 8 volts over here, and it then has 3 volts, and then it has 3 ohms, and then it has 2 ohms, then it has 18 ohms. So we have 2 voltage sources, right? Not to worry, we are going to follow our rules. So what does the rule says? You have to simplify the circuit, and then you have to have, normally it's used for this, but we now going to have 2 circuits. So we have 2 voltages, right? So let's simplify it. So we have voltage 1 only, and then we have voltage 2 only. Let's read the question. So the question is, find current in each branch, right? So that's a question. So let's start with the 8. So we have the 8 volts, 3 ohms, 3 volts, so we're going to ignore that one, 2 ohms and 18 ohms, right? Over here we have our 3 volts, 2 ohms, 3 ohms, 8 volts, ignore that, and then we have 18 ohms over here, right? So we need to find I1, I2, I3. Okay, so we have these two circuits, right? So this is your I1, I2 and I3, right? So now let's solve this equation, right? So so we need to know Ohm's law, guys. You need to remember Ohm's law by heart, okay? So to get current I1, I2, I3, first we're going to get total resistance, right? So total resistance is going to be 1 over 2 plus 1 over 18 all to the power minus 1 plus 3. Let me get my calculator quick. Calculator. 1 over 2 plus 1 over 18 to the power of negative 1 plus 3 equals 2. So we have 4,8 ohms. That's our total resistance, right? So what's next? Next is Ohm's law. So Ohm's law is, this is Ohm's law, right, students? So I1 would equal to V total over R total, and our total voltage is 8 volts, right? So then we're going to have 8 volts over 4.8 ohms, and then we have our current of 1,667 amps. That's your I1, right? Next, I2 and I3. So now we need to find I2 and I3. Let me copy this quickly. Copy. Paste. So I1 is equal to 1,667 amps, right? So now we need to find I2 and I3. So we're going to use the current divider rule, right? So the rule is the current at 2 is equal to the total current. So the total current multiplied by the adjacent resistor, the adjacent resistor the sum of the adjacent resistor over the sum of adjacent resistor plus the resistor at 2. So our total current is 1,667 adjacent resistor, our adjacent. So adjacent from 2 is 18. Can you see adjacent from 2 is 18? So our adjacent resistor would be 18 over adjacent resistor 18 plus 2. And then our current at 2 will be 1.667 multiplied by 18 over 18 plus 2 equals to 1, 1,5, 1,5, 1,5, 1,5 amps. So this is your I2. Your I3 is equal to I1 minus I2, which is equal to 1.667 minus 1.5, and we have 0,167 amps. So we have our I1, I2, I3. But remember guys that for superposition we only solved the first equation. We have to solve now the second equation, right? Let me just double check something quickly.
What you mean?
Okay, let's solve the next equation.
What's it?
Next equation. So first, what we're going to do is find current I1, then I2, then I3, right?
I can't believe it.
So, okay. So this will be, let's keep it the same. Sorry, let's keep it the same. I2, I3, I1.
You told me
Okay. I2, I3, I1. Okay. So now, basic Ohm's law, never forget it guy. Total resistance equal to 2 plus 1 over 3 plus 1 over 18 to the power of negative 1 equals to 2 plus 1 over 3 plus 1 over 18 to the power of negative 1. So we have 4,57 ohms. So this is the total resistor. Don't forget Ohm's law. So
you can join now.
V over IR. So our current at 2 is equal to voltage total over resistor total, which is equal to 3 volts over 4,57 ohms, and then we will have 3 over answer equals to 0,6576. So I2 will be 0,756. And now, so we have that one and that one, right? So we now have to find I1 and I3. So we're gonna just copy this one. Sorry. Copy. Paste. So our I2 is equal to 0,656 amps, right? And then we're going to do current at 1 is equal to the total current multiplied by adjacent current over the sum of the adjacent over the sum of the adjacent plus the current at 1. Okay, so we have resistor, so now we have the total current 0,656 plus adjacent resistor, which is 18 over 18 plus 3. So we have our I1, which is multiply 0.656 multiplied by 18 over 18 plus 3, 0.56 2, and then I3 is equal to I2 minus I1, which is equal to 0.656 minus answer equals to 0.093 amps. So there we have I1, I2, I3. So basically what we're going to do now for our answer. So our answer, let's use a different color. So our answer, I1 is equal to I1 plus I1, I2 is equal to I2 plus I2, I3 is equal to I3 plus I3. So the reason for this is because this is for source 1, source 1, source 1, source 2, right? So now our answer is going to be let's do I3. So we have 0,167 plus 0,093 I1, which is 0,562 plus I2, which is 1,5 plus 1.667, 1,667, and the other one is 0,656. Zero point 656 plus 1.667, 2,323. Then we have 1.5 plus 0.656, 2,156, 0.167 plus 0.03 equals to 0,26 amps. So this should be your answer. Another thing to note that is you need to focus on the sign. So it can be positive or negative depending on the direction, right? So positive or negative, right? So if you have a battery like this, that's gonna be addition, right? And then if you have something like this, that's going to be subtraction. So just keep that in mind. Pos- Negative, positive, negative, positive, negative, negative, positive, positive, negative. Yes, so just keep that in mind, and then I think that should explain everything to you. Thank you for asking that question, and see you in the next class where I'll explain in detail superposition and the rest of the theorems. Good luck on your studies, guys.